Today, ladies and gentlemen, we are going to be doing M7, lesson 8-10. And this is primarily focused on this concept called volume. Okay, to give you an idea of volume right off the bat, I want you to imagine a bathtub. Yep. Okay, that's a really nice bathtub. It's a jet tub. And we're going to put some water in this tub.
Make it yellow.
Okay, no, I'm not doing that. There's going to be no yellow water in this tub. Okay, here's a tub. Now, listen. Let's say that this tub was pretty full, and I decided to drop a baby elephant in it.
It looks like it has wrinkles all over it. It does.
Well, elephants are very wrinkly, so. Okay, so there's a baby elephant. I'm going to drop the baby elephant into the tub. Okay, so I can't get all of the baby elephant in the picture, but here we go. Now, in all seriousness, ladies and gentlemen, what would happen to the water? Okay, Jacob?
It would splash.
Okay, it would, I'm not going to say splash, because we'll ease the elephant into the water. Okay, the water would flow out. Why? Why wouldn't the water just go around the elephant and stay in the tub? Hang on, I'm going to give him a chance to answer this. This is really important idea here about what we're looking at with solids. It is, but why does it flow out? What does the elephant do? Okay, you're on the right track. Let's not use mass though, because the elephant's really heavy, sure, but what if we had a styrofoam elephant the same size? Let's just say that we pushed it into the water. Would the same amount of water flow out?
No.
I said it can't. I said we'd push it into the water.
Would it be the exact same size?
Exact same size.
It would be the exact same water flowing out.
It'd be the exact same water flowing out. So we know weight has nothing to do with it. It's the size of the object. The size of the object that takes up what?
Volume. Mass.
Space and volume. Okay, so here's the big picture. Every object takes up space. I think that's a pretty easy idea for us. We take up space. Right now, instead of there being air where I'm sitting, I'm taking up this space. If I move, what's going to fill in behind me? Air. You're right. Air is taking up space. Air is filling everything in this room where there isn't another object. All right, so the chairs take up space, but if I were to take all the chairs out, what would replace it?
Air.
Air. That's the main idea here. That's where we're going with this. Ultimately, we are going to be talking about the volume or the amount of space of two different types of objects. Okay, two different types of objects. So I'm going to kind of lay those out. The first one is a prism. And we're going to talk about the amount of space prisms take up. And we're also going to be talking about cylinders and the amount of space cylinders take up. And the big idea, the amount of space, we give it a very special, it's a very special word. It starts with V. It's called volume. Not to be confused with like how loud something is. All right, volume is the amount of space something takes up. And we're going to be looking at these two things specifically today. Noah?
It's like space, like out of the world space. If like something moves, what replaces it?
That's a great question. In outer space, when something moves, nothing replaces it. That's why objects in space can go on forever, because there's nothing to slow it down or there's nothing to move around it. Draw a little kind of rectangular square right there. And I'm going to go up a little bit. I'm going to draw the same thing. All right, and then draw a cylinder as well. I think cylinders are easier to draw. Sometimes it takes practice. The ticket is to draw the same object on the top and the bottom. So we have prisms and cylinders. And we want to find the amount of space they take up. Let's imagine for a moment that on our prism, we had one layer. Okay? That was one tall. Okay, I'm going to zoom in on this a little bit so it's easier to see. So I had one layer. You don't have to draw this. I wanted you to practice drawing the original figures. Let's draw it one layer, one tall. Let's make this 4. Let's make this 2. Okay, that layer is going to be kind of like its own piece of the puzzle, being only one tall. Okay, so there it is. There's the piece of the puzzle, and it's 4, 2, and 1 tall. All right, what would be the volume of this piece of the puzzle? What would be the volume of that? It would be 8 units, and because it's volume, it's actually going to be units cubed. Okay? Well, if you want to find, let's say, the volume of a cube, you do length times width times height. Length, width, and height. So we end up with 4 times 2 times 1. 4 times 2 times 1. 8 units cubed. Okay. Okay, I added another layer. What can you tell me about the bottom layer and the next layer?
They're both the same.
They're the same dimensions. They're both 4 long, 2 wide, and 1 high. So what could you tell me about the second box? What would be its volume? Anna? It would also be 8. Okay? So I know that the bottom one has a volume of 8. I know that the next one up has a volume of 8. What about if I added another layer here that's 1 high as well? What would its volume be? It would also be 8. Let's add another layer, and it's 1 high, and what would its volume be? 8. I'm going to go last but not least. I'm actually creating 2 here, because, okay, and so there's 1 here, there's 1 there. All right, I know each layer has a volume that's 8. How many layers do I have? I have 6 layers. 6 layers. Each layer has a volume of 8 units cubed. So that's like saying 6 times 8 units cubed. Jacob, what's 6 times 8? It's going to be a total of 48 units cubed. It's like adding up all the layers. But I've got a little bit of a shortcut for you. Okay, you don't have to do this for every problem. What if I were to have taken the 4 times the 2, and instead of adding up every layer, I just said that the bigger object has a height of 6. What's 4 times 2 times 6? 48. So ultimately, it's like I'm taking an object and adding up all the layers when I go ahead and I multiply by heights other than 1. I had 6 layers, or I had 1 layer 6 high. It doesn't matter. We don't have to necessarily find the 6 layers. I'm just kind of teaching you the idea here. Okay, so here's what we did. I found 4 times 2. Isn't that the base area? It is. It's the 4 times the 2. I found the base. And I multiplied the base area, the 4 times the 2, by the height. That's how I found volume. That's all you do. The base area times the height.